Lesson 22, looking at parabolas again. In the last video, we talked about parabolas that look like this. Okay, vertex specifically centered at the origin, being horizontal in direction, or even vertical in direction, facing up or down. In this video, we don't want to talk about them sitting at the origin anymore. We want to look at what if they're centered at a different point. Now, the information for this is actually very logical. If you recall how we had function shifted before. So, let me go ahead and talk about function shifted before. If I gave you y was equal to x minus 2 squared plus 3, what happened here? What did y equal x squared change? How did it change? What did it change in terms of? Well, the minus 2 on the inside says I'm going to move this thing 2 units to the right. Okay. What did the plus 3? That said I was using 3 units up. Now let me rearrange what I have here. Let me actually subtract this 3 to the other side. That gives me y minus 3 is equal to x minus 2 squared. Wait a second. If I put, say, a 4 and a p in front of this, isn't this just a parabola? And it's still shifted up 3 units up and 2 units to the right. And both those signs are subtraction signs. Okay? There's something very, very comparable for anything that we're working with when it's shifting left and right, up or down. The equation's still going to behave the same. Now, before we said that this was shifting up. It does exactly what we think it would do. Well, in reality, when I move it over here, it does the opposite of what I want it to do. But now both of those terms, both those things, the y minus and the x minus, both behave inversely to what we think they would behave as. Okay? So what that means is that if I look at 8, okay, and we talk about the equations there, the standard forms, and this honestly works for all of them. So really all the information we did on the last page in number 5 was completely useless in comparison to filling in this table right here. Okay, filling in this makes filling in, again, number 5 a waste of time. But that's okay. So, let's assume we have an axis, a vertical axis of symmetry. Okay, that means that my axis is going to go in a x equals fashion. Okay, and I'm going to have the parabola go something like this, which means that my x thing has to be squared. So I'm going to have x minus some number. What number would that be? Well, that'd be the h, okay, squared. So this shifts it again, left or right. And that will shift the vertical asymptote, or the vertical asymptote, sorry, the vertical axis of symmetry, left or right. So this is going to be equal to that 4 times the p, and it would have been just y, but now I have to account for the fact that this might be shifted up or down. This is the general equation for any parabola that is facing vertical or, facing up or down, vertical, okay? Where h comma k is the vertex. Okay. What does that imply for the focus and the directrix? Well, we have to deal with these very carefully. First of all, where was the focus before? It was p units above the vertex. Well, I mean, if the only thing that's really changed is this being shifted around and the p-value doesn't change, well, then the focus is really going to be p units above the focus. So if I'm moving it vertical, it's h comma k plus p. This is the generic equation for the focus. The directrix, well, that's going to be y equals still. I'm sorry, not y. Yeah, y equals, because the directrix would be down here. Okay, and it'd be equal to what? Well, the k value, I have to shift the point all the way to here. Okay, and then move it down p units, so k minus p. This becomes legitimately just a set of formulas that we just either have to memorize or, have written on a note card. Okay? I do not have these things in my head. They're not there. I remember this picture. Okay? This picture is a lot easier for me to play with. If I had this thing in terms of the other form, where it was a horizontal axis of symmetry, we're now going to have the y minus, it would be k squared, okay, is equal to 4p times x minus h. The h still shifts it left and right. The k still shifts it up and down. It just happens to be that now, with the y being squared, its face is in this direction. Okay, where my directrix is here, my focus is here. So where are all the changes occurring? Well, they're all occurring in the in the x direction now. Okay, so my vertex is still h comma k. My focus now is going to be h plus the p. Okay, because remember, we shifted this direction. We shift it in terms of x. So I get myself to the vertex with the h, and then I move over p units. Okay, make sure I shift in terms of k as well. Now my directrix will be what? Well, directrix is going to be an x equals line, and I go to the vertex. So in this case, I make sure I'm over to the x value h. So x is equal to h. And then what do? I subtract p from it. Again, these are general equations for the information on a parabola. Now, I'm going to give this to you guys in class, but I'm going to show you this right here. I have these all listed out. The general equation for the parabola, okay, when we see something like this, where the x is squared facing up or down, where the y is squared facing left or right, the vertices are the same. The focus adds p in the y direction for x squared. It adds p in the x direction for y squared. And the directrix is x equals or y equals the h or k minus the p. Okay, all this information is, again, just a matter of memorizing and being able to reapply. So, with that being stated, let's take a look at number 9. Number 9 says find the focus and the directrix. And it gave me this equation. And you're thinking, well, that's not in the form that we generally play with. Well, how do I get it in that form that we generally play with? Well, I want it in the form of, well, it's y squared, so I want y minus some k squared is equal to 4p times x minus h. That's the form I want it in. How do I get a binomial like this squared if I don't have it already squared? That looks to me like it's going to have to be completing the square. Now, hold on, okay? I know completing the square is not fun, and I told you there was a reason why we learn it. This is honestly the reason why we learn it, so we can play with all of the conics. Yes, all of the conics force you to use completing the square. Parabolas, ellipses, hyperbolas, and circles, all of them. So, what we're going to do here is we're going to review how to complete the square. First, what I'm going to do is I'm going to subtract the 3x and add the 4 to both sides. So I have 2y squared plus 8y is equal to a negative 3x plus the 4. The next thing I'm going to do is I'm going to get the y squared term to be just y squared. So I'm dividing both sides by 2. Now this might seem like it's going to be a lot more work than it needs to be, but this, trust me, will work better for us. So now I have y squared plus 4y is equal to this obnoxious looking thing on this side. Okay? Remember, how do I complete the square? Well, if I have y squared plus something, in terms of y, I need to add something to this side and add the same thing to this side to make sure that this thing is going to be something squared. Well, I take the middle term, that 4, I divide it by 2, and I square it. That's the rule. Now, I always, if you recall, said 4 divided by 2 is 2, and then I squared that. Why did I do that? Because that right there will be y positive 2 squared. That's what this thing here is going to factor into once I add 4 to both sides. Okay? So, this side becomes this side when I factor it, and this is equal to this thing plus the 4. So let's go ahead and deal with that. I'm going to factor out the 1/2 from this whole piece. I get negative 3x plus 4. This side here, I'm going to make sure I'm going to multiply this by 2 over 2 to get a common denominator, so it's going to be plus 8 over 2. Then I can factor out the 1/2 from everything. Now, if you don't like me doing that math, that's okay. We can always do it the good old-fashioned way, immediately changing this to be 8 over 2, and then adding the like terms. So I have 4 plus 8 is 12. So this whole thing is going to be a 1/2 times a negative 3x plus 4 plus 8, which is plus 12. And then out of these pieces here, I can factor out a, now again, notice I want it to be a positive x minus something or plus something. So I want this to be positive. I'm going to factor out a negative 3. By doing so, will give me x minus 4. And this value here tells me how much I'm shifting in terms of left or right. This one here tells me what I'm shifting in terms of up or down. And now I can find out how my focus is being moved and how my directrix is being moved by making sure that this thing right here is equal to 4 times p. Okay? So, that's going to give me y plus 2 to the power of 2 is equal to, I'm going to go ahead and solve for p. P is going to actually be equal to a 1/8 times a negative 3. That's the p value. So I have 4 times a negative 3 over 8 and an x minus 4. Again, this is exactly what I want it to look like. And now I have y plus 2 to the power of 2 is equal to 4 times my p value, negative 3/8, times the x minus 4. Let's talk about all the details now. It says find the focus and the directrix, but I'm going to find it all. Okay, what's the vertex? Okay, the vertex is specifically going to be, it says positive 2 up, so I'm going to go 2 down, so it's negative 2, comma, and then 4. Sorry, it should be 4, comma, negative 2. Again, the x value comes first, the y value comes second. So 4, positive 4, negative 2. That's my vertex. Now, for me to be able to find my focus, I had to find the vertex. Now, the focus is, well, wait, which way is this facing again? It's y squared, so if I look at the graph, it's going to be looking something like this, or like this. Okay, maybe I should actually draw it accurate based on the fact that my vertex at 4, comma, negative 2. Let me do that. 1, 2, 3, 4. 1, 2. With the p value being negative, I know it's facing in the negative direction. Okay, which means that my focus is going to be somewhere in here, which means that I have to subtract the 3/8 from the x value. So it's 4 minus 3/8 and a negative 2. That's my focus. Lastly, my directrix is going to be on this side of this graph, and it's going to be then an x equals line, and x equals what? A 4 plus the 3/8. Okay, the x value that is on the opposite side of that dot. Okay, so that covers example number 9. Again, the focus is can you complete the square and manipulate algebraically. If you have difficulty with that, I suggest you practice it.